Hey guys, this is Dr. Ray, and in this brief video, we're going to cover research, more specifically how to perform research in physical activity or kinesiology. I plan to talk real briefly on some of the ways that we acquire knowledge, more specifically the scientific method of knowledge acquisition, go over the different types of research, and a brief overview of the research process in which you as a graduate student will be using for your thesis or capstone study. So, how do we acquire knowledge? We are lifelong learners. We've spent many years since we were little kids trying to answer questions and find solutions to problems. So the approaches in which we use to acquire knowledge is what philosophers of science like to call the epistemological approach. Epistemology is simply the study of knowledge acquisition. And what are some of the ways that we acquire knowledge? Well, there's tenacity, which is just unsupported ways or beliefs in which we acquire knowledge, such as superstitions. And if you ever watched a baseball game and you're hoping for a walk-off home run, so you take off your hat and invert it, and you think that's going to somehow help, but obviously it's superstitious. So that is obviously a unsupported way of acquiring knowledge, and certainly has no place in science. In other words, intuition, that's just what we believe is common sense or self-evident truths. There was a time in which we believed that the earth was the center of the universe and everything revolved around it. It's called the geocentric belief. And then over time, we believe the science had told us that is not the case, obviously. Authority, we believed our parents, our teachers, professors, our faith leaders, our government leaders, that they tell us something we believed in was reliable. But it's always good to question the authority. Trust them if you must, but always verify. The rationalistic method is a method that we all use where we try to find degrees of association. A perfect example in the Thomas book, is in basketball players, where they say that all basketball players are tall, so therefore if Spud Webb is a basketball player, he must be tall, which if you follow basketball, we know Spud Webb is actually, I believe it's 5'7", so relatively speaking, he wasn't tall. Okay. The empirical method is a method in which we're using data. We acquire data based on objective observations or quantitative data. It sounds legitimate. However, it's only a small part, I don't say small part, but it's only a part of the overall scientific method that we use to obtain knowledge. Okay, so we can't rely 100% on just the empirical method alone. So therefore, that leads me to the scientific method, which really is the most reliable way that we provide, or that we acquire knowledge and provide evidence to the practices that we do in the clinic, in the training room, or out in the field. And this is not to be confused with what's known as bro science. Okay, I think we've all know the bro scientists out there. These are the guys who think they know everything. They've tried this new diet or tried this new training regimen and says, oh yeah, you got to try this, man, it really works. So this guy who's really fit, he's really woke, or they've used it and it works well for them. Or my favorite, it's science, bro. Google it, look it up. Okay, so you're in the fitness industry, you work in physical activity, physical fitness, you train, you're a strength and conditioning coach. I'm sure you ran into those pseudoscientists who, for whatever reason, believe a certain fad diet or a certain training regimen is most effective without any evidence to back that up. Just watch the documentary Game Changers and you'll know what I mean. Okay, anyway, that's a bit of a side note there. However, not all techniques, modalities are based on anecdotes. There are sort of backed up by science. And I'll take this for example. An anecdote would be, and this is the rationalistic method. This is a picture of Eliud Kipchoge, who broke the 2-hour marathon barrier a couple of years ago, and he was wearing these Nike Alpha Flies. These are, at the time, they were prototypes, and it was said that because of those shoes, he was able to break that barrier. So an anecdote, example would be one in which, if I were to wear those shoes, that somehow I'm going to run a marathon in another 2 hours. Not going to happen. In fact, if I were to wear the shoes, I'd probably end up like this guy. It's only because I'm not a trained runner. I could run 3 miles and it'd probably take me over a half hour to finish it, regardless of the shoe I'm wearing. So that's anecdote, that's a rationalistic method that has no scientific evidence to back that up. However, science has actually told us that these shoes return up to 4% of mechanical energy. So therefore, it improves running economy in these trained runners. In fact, you can just look up some of the recent research studies that have been published in the last, I'd say, 2 or 3 years that show that the biomechanics are significantly improved, if you will, by measures of improvement or performance, running performance, in these carbon fiber plated shoes. Okay, so that's one example that I show in which the scientific method was used to provide evidence to the effectiveness of these, we'll just call them modalities. So this is just kind of a spectrum of ways that we acquire knowledge. Some of these on the bottom here is what I like to call anecdotal evidence, where we are interested obviously in the scientific method. We are interested in evidence-based practice or evidence-based medicine if you're an athletic trainer, a physical therapist, or want to be a PT or a PA. So the evidence that we use to provide for all of our clinical practices and techniques that we do in a training room or in our strength and conditioning regimens is based on science, right? The good thing about science is that it's true whether or not you believe in it, as quoted by Neil deGrasse Tyson here. So we're going to focus on the scientific method of problem solving. And I've summarized here all the steps of the scientific methods into 4, and it's somewhat oversimplified, but just 4 distinct steps. Step 1 is to develop the problem. What research questions do you hope to answer with a research study? I think you as a student coming in already have some ideas of ways certain things work for you as a trainer or for you as a coach. So, you develop the problem. A research problem is just another way of saying a research question. Okay. Then you formulate the hypothesis. The hypothesis is simply what you believe are the answers to these questions, what you believe are the solutions to this problem. Then you sample research participants, you gather data that operationally define the measures by which these hypotheses can be tested, analyze, you interpret the results, and then you make your interpretations, findings from there. Those are the steps of the scientific method in which quality research is performed. So this steps could also involve identifying, delimiting the problem, the research question, identifying what's out there in the current literature, what evidence has been published in the last few years that either support or perhaps are inadequate in providing evidence for answering your research questions. This allows you to identify gaps in the literature. Then that allows you to specify those hypotheses that can be tested with your research study. Then we designed our research study based on the hypothesis to be tested. You then sample our research participants, collect data, analyze the data, and discuss the meaning and implications of these findings. Your research study is only as good as its relevance to current practice, right? And if you're in the business of sports medicine or sports performance, we're interested in 2 main things: athletic performance and injury risk. And we can measure or operationally define these 2 things using a number of biomechanical variables or exercise physiology measures such as VO2 max, for example, heart rate, things like that. I say that for another lecture, but these are some of the ways that we could measure and evaluate human performance and injury risk. So what are the 5 characteristics of research? Scientific research has to be systematic. Got to be able to plan, identify, design, collect data, and evaluate. And if you're in my research methods course, what we're going to be doing is we're going to be doing the first thing. We're going to be planning and identifying and designing a research study, and then propose that research study that ultimately you are going to perform for your thesis or capstone. It needs to be logical. The procedures need to evaluate conclusions. We got to be able to examine the procedures used to evaluate the conclusion. As I mentioned earlier, there's empirical. We have to have a decision based on objective data. Reductive, can we generalize, or can we establish relationships between variables in our data? And the methods have to be replicable. Can you give your research study to another student or to another colleague, and he or she should be able to replicate your study given the methods that you detailed in your method section, and then hopefully be able to reinforce your findings, whatever that may be. So what are the different types of research? I'm not going to go over detail, but the continuum goes from basic research, which is research conducted in the lab, to applied research, which is research that's conducted in natural settings of athletes and patients. This provides immediate solutions. And then in between there is what's called moderate relevance, where it's theory-based, basic research, but it also has a more direct relevance to applied research that basic research does not provide. The thing with basic research, these are typically done in the lab, and has the most amount of control by the researchers, but it's not in the natural setting of the athlete or patient, so its applicability may be indirect at best. I'll give you a perfect example. I work with baseball pitching, more specifically pitching biomechanics, and so we see a lot of baseball players in our lab, and it's cool. We are able to measure a number of kinematic and kinetic variables of their throwing action, but we all know that throwing in the lab is not the same as throwing either in the bullpen or, more importantly, throwing in a game. So we're not getting their natural environment. So in a way, I like to call it's more of the level 2 type of research. It's moderate because we're getting the throw off amount. And with current technology, we're able to measure these biomechanical variables in their bullpen, at their outdoor bullpen. However, it's not in their natural setting. It's not applied research. Now, with today's technology, with markerless technology, markerless motion capture, and wearable sensors, now we are able to measure the biomechanics of pitching in their natural setting, in their natural competitive environment. So that's an example of level 3 applied research there. I'll go over this real quickly, the different types of research that you'll find in the literature that perhaps you potentially will perform as part of your career. There's analytical, where you're looking back, historical data, looking at reviews, systematic reviews, or meta-analysis, which is a statistical analysis of multiple data sets from different studies. Research can be descriptive in nature, where you just simply want to know, the characteristics of a certain population. The perfect example is a survey. You want to survey basketball players and, perhaps get their feelings about, after a game or pre-game, and you do a questionnaire. Descriptive research could also be a correlational study or an observational study, where you're looking at a specific group and determining relationships between certain behavior patterns or certain risk factors and injury risk. Epidemiological research is filled with a number of case control studies and correlational studies, where we're trying to find the relationship with certain risk factors such as cholesterol level or heart rate or BMI to certain diseases such as cardiovascular disease, obesity, diabetes, etc. Most of the work that we do in kinesiology is experimental in nature, meaning we actually control the independent variable and apply a certain intervention to our participants. So if you're interested in, HIIT, you want to know the effects of HIIT on vertical jump performance, you may design and perform a randomized control trial in which one group does HIIT and the other control group does something else, and some more traditional type of training, and you're measuring vertical jump performance and seeing pre and post what the changes are. So that is a research study that's experimental in nature. With qualitative research, this uses a different paradigm, and typically they use interviews with a small number of research participants, and you're trying to find a certain behavior pattern or a certain attitude towards some kind of intervention or some kind of training regimen. So this is more subjective in nature, but it does have a place in quality research and kinesiology. Okay. So how do we deduce these hypotheses that we ultimately test? There are two kind of forms of logic. One is inductive and one's deductive. In inductive logic, these hypotheses are largely based on observations that we make either in the field, in the training room, or just in practice. All of us, those of us who are clinicians, coaches, have certain observations that we make, and we hypothesize that the majority of athletes or the majority of patients that fit that description observe or do or behave the same way. So that is the logic of induction. Deductive logic is our hypotheses that are logically deduced from existing theories that are relevant to our field of study. So typically this just comes out from a series of research studies, and we read what's in the existing scientific literature and begin to logically deduce our own hypothesis based on the gaps of data in the relevant literature. So these hypotheses can be drawn from deductive reasoning or from inductive logic, as shown here. So what I show in this slide is it's an oversimplified, if you will, flow chart of the research method, of the research study. So you've got your hypotheses here that we ultimately we wish to test. We operationally define the measures by which performance or injury risk can be evaluated. These are what's called the dependent variables or outcome measures that operationally define, like I said, risk and performance. So for example, injury risk, how do you measure that? And say, if you perform 8 weeks of neuromuscular training, that's going to reduce the risk of ACL injuries. But we need to actually operationally define risk. And some of the ways we do that is using biomechanics. This is typically called modifiable risk factors. And we found through research that knee valgus torque during a drop vertical jump or a single leg hop has been shown to have a significant relationship to the incidence of knee or ACL injuries. And so therefore, valgus torque in this case operationally defines injury risk particularly for female athletes. And then we design and execute our research methods. This includes our sample, participants, our data collection techniques, whatever that may be, either biomechanics or exercise phys, some other modalities that we use to collect data, the procedures or the protocol that we use, the statistical design. We then collect, analyze the data, interpret the findings, and we discuss those findings in the context of existing literature, as well as develop new questions. We may find more questions than answer at the end of our research studies, and so then we formulate new hypotheses. This is the flow of research. It is the reason why many researchers stay in their field of studies, because we always come up with more questions. I've been performing baseball pitching research for the last, I would say, 12 years, mainly in shoulder and elbow injuries. Why? Because shoulder and elbow and injuries remain prevalent, pitching-related injuries remain prevalent in baseball and all levels of baseball today. And we know it's biomechanically related. So, we continually find answers, but we also find more questions as well. And so that's kind of the cycle in which we perform research. So you as a graduate student, one of the first things that you will be doing is formulating a research question. You already come in having all these questions in mind. Our job, if you're taking my research methods class, is to narrow that question so that it becomes a research problem that we can solve using a hypothesis that's ultimately testable. So what is the criteria for selecting a research problem? What interests you? What do you see in the clinic or in the training room, in the gym, that perhaps would be worthwhile to investigate, right? Some of you have ideas in terms of training regimen or a certain technique that you feel is more effective and you want to get that tested. Or if you're interested in sports nutrition, you're interested in some kind of plant-based diet, or intermittent fasting, or some format of that, and you want to test, well, can you develop a research question and problem, and then subsequently a hypothesis that can ultimately be tested. So what I included here is kind of the standard format that we typically use for a thesis or a capstone, but really this is a standard format that is used for any research article or research study. So the proposal, if you're taking my research methods class, involves your plan. And that mainly involves the introduction and literature review, as well as the methods. These are obviously important parts of your thesis, of your proposal. The introduction and literature review describes the background on which your research study is based. It provides a review of existing data in the current literature, as well as identify gaps in the literature. So ultimately you come up with the purpose of your study, as well as the hypothesis you wish to test. Then the methods here include your sample, your instrumentation, the procedures that you use, the statistical design and analysis that are used to test the hypothesis of the research study. And then after you perform the study, you come back, you present the results, your discussion and conclusions, and all of this introduction, methods, results, discussions, and references make up the standard format on which the thesis, the capstone, and any research article is based. Well, that was research methods in a nutshell, or at least the introduction to research methods. View the next video here to find more detailed information on how we perform research in kinesiology and exercise science in general. Thank you.